In the previous video, we did amazing result of bypassing all vendors from anti-scan me. But what if I tell you that the results might not be that great if we are up against a real lab with a bunch of antiviruses? So let me explain. When uploading stagers to anti-scan me, we cannot be sure about the results, if they are false positive or not. That's because of network segmentation. The AV vendors there cannot really scan the shellcode because they don't have a way of downloading it. It's configured for my network, it's not exposed anywhere, so they don't really have a way of seeing what's being run, and that's why we flagged 0 out of 26. I'm sure that if we were to implement and test that into real lab containing these antiviruses, a lot of them would catch our stager because we are using msfvenom stageless payload, which is well known with well-known signature. What that means is that we bypass signature-based detection. Signature-based is the detection type when it scans the file for non-signature, non-bytes, non-payloads that are counted as malicious. After that being scanned, it goes to heuristic-based detection, which pretty much tries to run the executable in sandbox environment, trying to determine if that thing is actually malicious or not. So it's gonna run it in sandbox environment, try to determine what it's doing. If it suspects something, for example, malicious IEX calls or stuff like that, it's gonna get triggered as a malicious. That's why we need to encrypt the shellcode. And now let's bring up to the main point, XOR encryption. So basically, XOR is an algorithm which is easy to implement and is reversible, which is nice and suits amazing for our job. XOR messes around with the bytes, looping through every single one of them, encrypting them with a key we can specify ourselves. And the main point is that we can store our shellcode encrypted, so the heuristic-based detection cannot see what that instructions are and what the shellcode is really doing. Now, in order to execute it, we of course need to decrypt it, and that's why XOR is so suitable because it's reversible. So we can encrypt it, store it that way, or download it encrypted, decrypt on runtime, and execute. So I know it's gonna be fun. Enough of theory, let's go. Alright, so it's time to see how the XOR encryption is behaving against various antiviruses. So let's start by explaining the environment, and of course we have my command VM right here where we're gonna develop the whole thing, and then my carry where we're gonna pretty much create a shellcode and set up a listener. Alright, so on my command, the idea is very simple. We're gonna generate a shellcode like with msfvenom. We're gonna store it and create a file called encryptor which is gonna encrypt the shellcode with a given key, custom key. Then we're gonna develop another program which is gonna be another shellcode runner, but we're gonna implement decrypting before running the shellcode. So we're gonna use our previous shellcode runner as template called sr.c, which we used in the previous video. If you haven't found it, you can find it right above my head, like right here. But if you haven't, we're gonna walk through a little bit of it to explain in a nutshell how does it work. So let's start by creating our encryptor to encrypt the payload we supply. So go open the dev C++, new file, include stdio-h.h, and define the main method. Now here I'm gonna test it with a custom string. So I'm gonna do like unsigned char and call it like code as the previous one. And we're gonna specify that to be like test. Alright. Now here we need to specify a key. So I'm gonna set up my key, which is gonna be char key is gonna be equal to, let's say, k. And it's really important to have single quotes instead of double quotes, and why I'm gonna explain a little bit later. Then we're gonna need to get the size of the array, but we can do it in runtime while getting to a loop. And we need to define a loop variable which is gonna be int I is gonna be equal to 0. Alright. Now what we're gonna do is do for I less than size of code, we're gonna do I++. And now here, what we're gonna do now is we're gonna printf percent slash slash percent 20x x percent 20x. I believe that's syntax. If not wrong, I can check it out if it's wrong. And that we're gonna printf the code of I with the XOR key there. So we're gonna specify the key. Now what that's gonna do is, if it works fine, we should have a nice little hexadecimal code. So let's call it encryptor.c, run it, and I'm not sure that that's it. So let me check about that printf syntax. So //x% O2, not 20. Oh my god. All right. And that's more like it. So that's the sort payload we need. All right. Now that's the encryptor. And let me show you what happens if we use the double quotes. So I'm going to remove the single ones, place double, save it, and run. And as you can see, we have different shellcode there, different values. But the interesting thing is that no matter what key I supply, for example, if I type B, we can see this shellcode is being simple, is being the same, which means our XORing is not working, which means it's useless. So we're gonna do it with single quotes, and as you can see, we have B now, it's ending with 42. We have key K now, and it's ending with 4B. So it's working. Alright, so now we're gonna create a fork of our shellcode runner. So let me open it up. SR. Come on, and we're gonna make a copy of it, save as SR XOR.c. Alright, save. What we're gonna test first is how we decrypt that thing. We want to get that test value after running through the XOR algorithm. As I said, the good thing about it, it's reversible and it makes the thing a lot easier. So I'm gonna copy my code to here. After all, or actually, I'm gonna copy first my buffer variable, which is gonna be here. Code is gonna be equals to, instead of test, now it's gonna be equal to the code we have from the output. So we're gonna copy that, and it comes right here. Alright, so that's the XOR payload there. Now let me copy my code, and we need to do a little modifications there in order to make it work. So the key must be the same, obviously. Now the size we need to do -1, alright? And here, instead of printing, we need to reappend to the array. So we're gonna do remove the whole print statement, and I'm gonna do code I is gonna equal to code I of XOR key. Alright. Now for the moment, I'm gonna comment that thing out because I don't want to try to execute anything whatsoever. And if I run that, I should get a test message. And I forgot to print it. So let me just do printf %s maybe. I'm not sure it's gonna work with %s, but let's just try it. Run it, and we have test. So we can see and confirm that our XOR payload is working. So let's now generate a video shellcode. So here I'm gonna type msfvenom payload Windows shell reverse. Yeah, you know how it goes. And with the format, we need to be in C. And here I'm gonna set up my endcat listener there. We are by purpose choosing stageless payload because we are testing various kinds of like AV bypassing techniques. For example, even though we use stageless payload, we were able to bypass Defender by simply staging. Even though the payload was stageless, it was downloaded in runtime, it bypassed Defender. So that's what we're gonna test now. So let me copy the buffer variable there, go to commando, and now first go to encryptor, and instead of testing, we're gonna need to change that thing into like our real shellcode generated from msfvenom. Now by running the thing, we can see we have a bunch of data there. So let me just copy that and paste it here. Alright, now it should be fine. And now instead of printing, because I'm not really interested in printing stuff, we can directly try to execute that thing. So let me see, we have the value code here, we need the size of code, we need the code here, and I think that's pretty much it. So we have the key, we're gonna whoop through it, we're gonna decrypt it and execute it. Alright. So I think we're good to go. So let me go there and ensure that my listener is being ready. Now let's run the program. The shell hangs, which most likely means we have a callback. Nice. So we can verify that our XOR payload is indeed working. Now, of course, the fun part comes. We're gonna pull that thing into anti-scan me, and we're gonna pull that thing, actually move that thing into my Windows 10 client. So we're gonna test it like from two perspectives. First, of course, gonna be anti-scamming, but I believe that if the API is working now, because at the moment I was attempting to record that video and testing the payload, it was not working again. I'm not sure what's going on with anti-scamming, but it's just the way it is. So we're gonna test the things with two attack vectors because anti-scamming is genuinely, as I said before in the video, can perform false positive, even though now I believe the result's gonna be aesthetic because we have the full shellcode there and it's gonna be decrypted. We are not gonna download anything remotely, so it is what it is, and it's all here. So I believe that anti-scamming should get like uh more more true results. So let me see. Let me just compile that thing. It's called SRX or .c. So we're gonna look for SRX or .exe, open that, scan it, and let's see what happens. So it looks like it works. The API is functioning. So let's cross fingers and see how many things we bypassed. Come on. 8 out of 26. So I believe that by memory, my standard shellcode, actually we're gonna test it out. I mean, 8 of 26 is not a bad result. Alright. Since that is working, I'm gonna upload my standard shellcode runner to see how does it behaves there. I think like 60 was able to catch it. So let me try. Let me open that file. Open sr.c and just compile it. Right now, browse sr.exe scan file. I believe like 60 was able to catch that thing. So let me see now. Yeah, 60. All right. So by simply performing XOR encryption, we were able to pretty much lower the rate by 2. Like that's a lot. That's a lot by 2x. So as I like to say, AV evasion is not like a single bullet that goes through every single antivirus, but it's like a set of techniques that helps and bypass one antivirus, another, and if you implement like 4, 5, 6, 7 techniques in your dropper, you can get a slightly low detection rate. So from the results here, we observed that Windows Defender was getting the shellcode in both of the ways. So let me just test it out myself, just to be sure. So let me just log in with my Windows 10 client. And what we're gonna do next, if that thing is indeed getting caught, we're gonna create a staged payload right here. Actually, let me just create it right away. We're gonna repeat the process and test it out with staged payload, which should lower the detection rate. All right. We're here and we are lacking VM2s, so we're gonna manually download the file with PowerShell. So on my commando, I'm gonna do ipconfig, I'm gonna do python, actually ls, I'm gonna do python mhttp server 80. I'm gonna copy my IP address right here and download it right away. So copy is not supported because I don't have VM2s. So I'm gonna manually type anything. I'm gonna cd into desktop and do invoke web request, HTTP, my IP address. Alright, and I believe it was so bad with memory. We have sr.xor.exe. Alright, sr.xor.exe. I'm gonna output that into, let's say, sr2.exe. So test in 3, 2, 1, and we get caught. Alright, so that's not gonna work. And we can say that the anti-scan is valid there because it claimed that Defender is gonna catch that, and indeed it does. So let me try now to repeat the same process, but that time with staged payload. Alright. And why the heck I'm honestly not sure why the staged payload is bigger than the stageless. So when I generate stageless, it's like 460 bytes, as far as I remember. And now the staged one is like 500 and more. Yeah, as you can see, stageless is being 460, and we cache the shell with netcat, so I'm not going crazy. The staged payload is bigger, so I believe that there can be some kind of obfuscation or just empty characters for something, I'm not sure. But let's test it out to see if we can bypass defender or lower the detection rate. So I'm gonna repeat the whole process again. I'm gonna go here, go to encryptor, and replace the code with the new one. Go with code and run that thing. All right. So let me copy the payloads there and go to SR XOR. All right, and do it like that. Ah, come on, don't make me do it. All right, unsigned char code is gonna be equal to the payload we have. All right, I guess that should be it. So let me first verify if that thing is working. In order to verify, we're gonna need to set up a metasploit to the MSF console because since it's staged, netcat is not sure what to send, how to handle things. That's why we're gonna need metasploit. So come on. I need to fix my Ruby errors there, warnings. So use exploit multi handler. Alright, set payload, Windows x64, shell, reverse TCP staged, yeah. Set lhost, ETH0 and set lport 443. So I should be good to go. I'm gonna do exploit now and let's see if that thing is working. So let me just run the program. The shell hangs again and most likely it does. Alright, so we have sending stage and pretty much we have a shell. Alright, so I'm gonna cut that, set up a new listener, and now let's play around with that body. So let me just recompile that thing, or just to be 100% sure, I'm gonna remove that SRX or exe whatever of that, and I'm gonna build it again. So let me just close that thing. Just make sure not closing the wrong terminal. Build it again, and we have it here. All right. So the strange thing is that I see dots here, or no, it's just never mind. I'm going crazy. Never mind. It's all fine. All right. So here I'm gonna try to download it once again. Let's see what's gonna happen. Run, and we get caught again. So in the previous example, when we had the stageless, we always get caught by the defender, and we had the 8 out of 26 detection rate. So let me try it once again. I'm gonna browse, navigate to that XOR sr.xor.exe scan file, and let's see if we get like 6, 7, or more, 8, 9. I'm not sure what's gonna happen now, so we're testing on that on runtime. Come on. And we still have the same detection rate. So it doesn't really matter since it's staged or stageless, since I believe that these are both msfvenom payloads and they are known to pretty much all the antiviruses. So maybe that's why. As you can see, we achieved slightly nice reduction of the antiviruses, but we have a lot of way to go. So I believe that if we implement staging plus XORing, that's gonna make the things easier and better. I'm gonna leave that for the next video because it's already like 20 minutes, and I really hope you learned something new. Even though we weren't able to bypass Defender, we achieved a decent detection rate reduction. So I'm happy with myself, and you should be too from yourself. Thank you everyone for watching, and of course if you have learned something new and if you enjoyed the video, make sure to like, subscribe to the channel, and of course share your feedback. So, see you right in the next one.